What up, athletes? Whoop, whoop. All right, let's do this. This is 11.6, and our learning target today is I will factor trinomials into two binomials. So I will factor trinomials into two binomials. Just rolls off the tongue, doesn't it? All right, so what we have here for the warm-up is a set of diamond problems. If you don't remember how to do a diamond problem, I'm going to do one real quick and demonstrate it. What you do is you take these side factors, you multiply them to get the top, and you add them to get the bottom. And we use it for problem solving because we're going to give you different parts of that. So you have to problem solve, like on this one, what could I multiply by 16 to get -8? And then once I find that out, I add them together to get the bottom. Go ahead, take a minute, pause this, finish these up. Ready, set, go. Okay, assuming you pause this, let's move on. -8 times 7 is -56. Add them together, I get -1. What can I multiply by 16 to get -8? Well, we know it has to be negative, right? And then, aren't I cutting it in half, so -1/2? When I add those together, I get 15.5. You're welcome to change it to an improper 31/2, that's fine. What can I possibly multiply to get 0? There's only one number you can multiply by to get 0. Boom. And what do I add to 0 to get -2? Well, I'm going to add -2. So when it's a 0 up top, it's real easy. Whatever this is up bottom, on bottom, that's what you're going to add to one factor. The other factor is going to be 0. Another fun fact, whenever the bottom's 0, that means I have to be multiplying the same exact number except one positive, one negative to get the top number. In this case, so let's look at -144. We know it's negative, but just take the square root of 144. What is it? It's 12. So it's going to be positive 12 times -12. Positive times negative gives me a negative up top of 144. Add them together, and they come to 0 down below. Awesome. All right, let's go look at the vocab for today. Oh, prime polynomial. It's a polynomial that cannot be written as a product of two polynomials with integer coefficients. In other words, for our purposes, it's a polynomial or a trinomial that's not going to be factorable into two binomials with integer coefficients. So pause this again, write this down because I'm going right to the next resource. Ready, set, go. And again, whenever I say pause this, that's your chance to pause it. I'm going to wait about 2 seconds to move on. We are going to write down today's key concept, which is factoring trinomials with a leading coefficient of 1. So something in the form of x squared plus bx plus c. We are going, and you're only writing the symbols in example. You'll notice that area on your paper. And what it is it's equal to the two binomials, x plus m and x plus p, when m plus p equals b and m times p equals c. That'll make sense in just a moment. So if I have x squared plus 8x plus 15, we can factor that to x plus 3 and x plus 5. Why? Because 3 plus 5 is 8, which adds up to be the center, and 3 times 5 is 15, which multiplies to be the last term. We're actually going to do this in a different way. I'm going to leave a little area in your example because I want to walk through it. Kind of cut your example area in half. And so pause this, write this down, these symbol and example, and then I want to show you what we're going to do. Okay. So notice I've cut this in half. I'm just going to draw this little diamond like we were doing up above. There's a purpose we had you use those for. Make yourself a generic rectangle like we were multiplying this out. So what's really cool is we can actually set these up. And we have an example down here that we're going to do in more detail, but I want to show you that this works. So notice we said that it works because, so let me just write down the example. We have x squared plus 8x plus 15 equals x plus 3 times x plus 5. And that's because 3 plus 5 equals 8, and 3 times 5 equals 15. Here's what's really important about that 3 and that 5. Is notice when we do a diamond problem, right? You can see it down here right now for you. Well, I'll write it up here. we multiply, or we find the product in the top, and we add to get the bottom. Well, it looks like we're adding here and multiplying here. So watch what we're going to use. We're going to use this fact. Remember when we were factoring, we're not factoring, but multiplying the binomials to get the trinomials? So we'd take these, we'd put them around the generic rectangle, we'd multiply them out. Well, remember how I said this is always, we had one diagonal that always had the first term and the last term in it. So I'm going to take the first term and the last term and write them in this diagonal. Now this middle term is important. Remember that second diagonal I told you always adds up to the middle term? So we know that if I knew what these two numbers are, they would add up to 8x. Here's what else I know. These two diagonals will always multiply out to be the same number. I'll prove it in just a minute. So if this is x squared times 15, that's going to be 15x squared. So what I want to find out is what two factors will add to be 8x and multiply to be 15x squared. Well, let's see. What numbers can I multiply? I always look at the multiplication side first. What can I multiply to make 15? 3 and 5. Do 3 and 5 add up to, well, 1 and 15, but 1 and 15 can't add up or subtract to 8, right? It's going to be 16 or 14. So then I have to be able to say, okay, 3 and 5. 3 plus 5 is 8. 3 times 5 is 15. So I'm going to write an x here and an x here because they have to be x times x is x squared. So I'll have 3x and 5x. And I know that 3x plus 5x is 8x. 3x times 5x is 15x squared. Now, it doesn't matter which squares you fill these up with. You pick. So 3x, 5x, I picked that. Now we're going to factor out. I'm going to look at just this row right here. So let me zoom into that for you. So x squared and 5x, what can I pull out of that? I can pull out an x. How about 3x and 15? What can I pull out? A 3. Now I look and I say, what times x is x squared? X. And does that work? 3 times x is 3x, so that works. Then I'm going to say, what times x will give me 5x? 5? Well, look at that. 5 times 3 is 15. This outside is now our factors. X plus 3 and x plus 5. Look at that. And that's how we're going to be factoring trinomials. So let's do this again. I'm going to look down here again. First and last term are always going to go in the first diagonal, x squared and 24. This middle term is always going to go in the bottom because it's the sum, 10x. And then I multiply this diagonal to get the top, 24x squared. Now let's think for a minute. What can I multiply to get 24? Well, I've got 1 and 24, but that won't add or subtract to make 10. Okay? I've got 2 and 12. I could do 12 minus 2 to get 10. The problem is if one of these is negative, negative times a positive would make this a negative and this positive, so that won't work. Then I've got 4 times 6. Wait, 4 times 6 is 24, and it adds to 10. So let's do that. 4x, 6x. Again, adds to 24, or multiplies to 24x squared, adds to 10x. So let's write it down. Doesn't matter which order again. Last time I put the left down here, so this time I'll put the right down there. So 6x and 4x. You can try it opposite, you'll get the same answer. Then I look up here. I say, what can I pull out of both an x squared and a 4x? So I'm just looking at this row right here, factoring this row. And I can only take out an x. How about in this row? What can I pull out of a 6x and a 24? Pull a 6 out. Then I start thinking about areas, length times width. So x times something is x squared. Well, it's going to be times x. And that makes sense because 6 times x would be 6x, and that's what it's supposed to be. Now let's go here. X times what is 4x? X times 4. And that again makes sense because 4 times 6 is 24. So what are my factors? If they're positive, it's a plus, so x plus 6. Oh, you can't see that, so sorry. And x plus 4. Boom. We're going to do more of these. Let's go. Take a minute. Try to solve the top two if you can. Pause this. And then I'm going to boot scoot through them so we can just roll through this lesson. All right. So again, x squared, negative 11, and then the middle goes in the bottom, 10x. Now we're going to have a negative. Negative 11x squared. Well, let's see. To get 10, I can do, or to get negative 11, I can really only do one thing. It's 1 times 11, and I need it to be negative, and I need a positive 10. So I know I'm going to have a negative, right? And I'm going to have a positive. And I know I'm using the numbers 1 and 10. Or 1 and 11, excuse me, because 1 times 11 is 11. It's a prime number. It's the only way to get it. However, I need the bigger number to be positive so that when I add them together, it's going to be positive. So I want the 11x to be positive, and then a negative 1x, which we can just say negative x is fine. So then, let's try that. Negative 1x times 11x is negative 11x squared. 11x minus 1x is 10x. Perfect. So let's do this. Negative x. And I'm going to put my 11x right up here. And watch what happens. What can I pull out of x squared and 11x? An x. How about negative x and negative 11? I can pull a negative 1 out. Now, what times x is x squared? X. X times negative 1 is negative x. What times x is 11x? 11. And 11 times negative 1 is negative 11. So my answer is x minus 1. And x plus 11. And no, this order doesn't matter. If you wrote it down as x plus 11 times x minus 1, that doesn't matter. Okay? Awesome. Let's do this one. X squared minus 24. Again, middle goes down here. Negative 5x. Add these two together. I get negative 24x squared. Well, let's see. It's not 1 and 24. Not 2 and 12, that's not going to make negative 5. 3 and 8, ooh, that might work. What if I did, and I need it to be negative, so I want it to be negative 8x and positive 3x. Look at that. Again, order doesn't matter. We'll put 3x, negative 8x. Let's do that. Up top, I can take out an x. Down here, I can take out a 3. X times x is x squared. Perfect. X times negative 8 is negative 8x. And I end up with x plus 3x minus 8. Take a minute, try this third one, extra example 4. Okay, did you run into problems on this one? You may have. Here's why. X squared, 24, makes a positive 24x squared. In the middle here would be negative 2x. Here's the problem with what we're dealing with. The only way I can get a negative down here and a positive up here is if I have two negatives I'm multiplying by up here. But can you think of two numbers that will both subtract? So I'm negative getting more negative, right? Like negative 1 and negative 24 is going to make negative 25. Negative 2 and negative 12 is going to make negative 14. Negative 3 and negative 8 is going to make negative 11. Negative 4, negative 6 is going to make negative 10. That's the smallest possible I can get. There's no way I can find two negative numbers that multiply to a positive 24x squared and will add to a negative 2x. Because of that, this is called a prime polynomial. So we would call this prime. There is no integer coefficient. That's why we had this at the front. Well, I have it over here. There is no, cannot be written as a product of two polynomials with integer coefficients. In fact, I tried this one using a thing you'll learn later called the quadratic formula, and it actually has no solution because it uses a negative square root, which we can't do. So that goes into imaginary numbers, which you don't need to worry about. Just know this doesn't factor. Okay, and our last one right here. Ooh, now we're going to have a coefficient on the x squared. Same process though. 7x squared, negative 2, negative 5x. Doesn't change a thing. Those multiply out to be negative 14x squared. How do I get 14? Well, 1 and 14, or 2 and 7, which 2 and 7 can subtract to be 5, right? Or negative 5. And since I want the negative to, I want the number on bottom to add to be negative, I need a negative 7x and a positive 2x and a positive and a negative multiply to be negative. So let's do it. Negative 7x and 2x. Up here, what can I pull out? Still just an x. What times x is 7x squared? Or I'm sorry, I'm not down here. What can I pull out of a negative 7x and a negative 2? Negative 1. What do I multiply times 7x squared? 2x to get 7x squared? Well, 7x. 7x times negative 1 is negative 7x. Perfect. What times x is 2x? Well, 2. So my answer is x minus 1, 7x plus 2. Boom! The world of factoring with generic rectangles and diamonds. I love it. And let's get rolling. So with that said, peace out.